Neutrinos build a ghostly map of the Milky Way. Astronomers for the first time detected neutrinos that originated within our local galaxy using a new technique. From ghost-like particles, astrophysicists have pieced together a new map of the galaxy we live in. For now, that map of the Milky Way is blurry and incomplete. But as more data is gathered, it will become clearer and will help illuminate galactic convulsions like the expanding remnants of exploded stars, providing clues to mysteries that are difficult to solve with only observations from conventional telescopes. This is the first time we've seen our own galaxy in anything other than light, said Naoko Kurahashi-Nielsen, a professor of physics at Drexel University in Philadelphia, who came up with the idea that a new view of the galaxy could be gleaned from particles known as neutrinos. Dr. Kurahashi-Nielsen and the more than 350 other scientists who collaborate on analyzing data from a neutrino detector at the South Pole reported their findings in a paper published on Thursday in the journal Science. This is at last really the beginning of neutrino astronomy, said John G. Learned, a physicist at the University of Hawaii who was not involved with the research. For as long as people have looked up at the night sky, they have seen the band of diffuse light from stars within the galaxy. Sophisticated telescopes have surveyed the Milky Way across the spectrum of light, from radio waves to ultra-high energy gamma rays. But those are all forms of light. Neutrinos are completely different. They are particles that are ejected from a variety of subatomic reactions and are one of the most common particles in the universe. But they weigh next to nothing and rarely interact with anything. At the bottom of the Earth, scientists have turned a quarter cubic mile of Antarctic ice into the IceCube Neutrino Observatory. The ice provides enough mass so that 1 out of every million neutrinos passing through will hit something, releasing a flash of light that can be captured by more than 5,000 photomultiplier tubes frozen into the ice. Over the past decade, IceCube has detected hundreds of high-energy neutrinos that originated outside the solar system. In 2017, other telescopes pinpointed the origin of a neutrino detected by IceCube to a galaxy 4 billion light-years away. Delving into their archive of data, IceCube scientists discovered that this galaxy had also burped neutrinos in 2014 and 2015. Last November, the IceCube team reported the detection of about 80 neutrinos from NGC 1068, a galaxy just 47 million light-years from Earth. Those neutrinos were most likely spewed out as the supermassive black hole at its center voraciously gobbled up matter falling into it. Somewhat curiously, there were no neutrinos that astronomers could confidently say had come from within our Milky Way galaxy. In some ways, that was not surprising. The black hole at the center of the Milky Way is much quieter than that of NGC 1068, but astrophysicists expected there were other phenomena that would generate enough high-energy neutrinos to show up in IceCube. One obstacle to linking neutrinos to events in the Milky Way was the placement of the IceCube detector in the southern hemisphere, where our galaxy is most readily observed. You would think it's better because the detector is in the southern hemisphere, Dr. Kurahashi-Nielsen said. But instead, particles created when high-energy cosmic rays hit molecules in Earth's atmosphere wash out the neutrino signal astronomers usually look for. It's almost like trying to see the Milky Way in Los Angeles, Dr. Kurahashi-Nielsen said. Around 5 years ago, she had an idea. Instead of the neutrino signals the astronomers had focused on until then, long tracks of light that helpfully point back to their distant origin. Dr. Kurahashi-Nielsen wanted to analyze the spherical cascades of light that neutrinos can also generate within IceCube, which are not as helpful for determining the origins of the particles. It's like a blob of light, she said. We used to just throw it away in terms of astronomy. But the blobs are not completely symmetric in all directions, just as a rock thrown into a pond creates ripples that are not always exactly circular, so a direction for the neutrino could still be inferred. I think most of my collaborators didn't believe this was viable back then, Dr. Kurahashi-Nielsen said. You want to push the envelope, but you don't want to do something that's impossible to do. So you have all these ideas that are at the edge, and you have to pick one that you think might actually work. Steve Sclafani, a graduate student working with Dr. Korahashi Nielsen at Drexel, who is now a postdoctoral researcher at the University of Maryland, and Mirko H. Neufeld, a graduate student at the Technical University Dortmund in Germany, spearheaded the analysis, taking advantage of advances in machine learning, a branch of artificial intelligence. "We are really doing a needle in the haystack search," Mr. H. Neufeld said. To avoid the possibility of deceiving themselves, the analysis of 10 years of IceCube data was performed blind. The researchers did not look at any of the intermediate results, and the scientists did not know until the end whether their analysis had turned up any Milky Way neutrinos at all. "It was fully possible that we opened up that box and we saw 0 Dr. Sclafani said. Instead, the analysis turned up hundreds of neutrinos that came from the galactic plane of the Milky Way. There appears to be some correlation between neutrinos and gamma rays, the highest energy form of light. Both are created in the cascade of particles that spill out when high-energy cosmic rays slam into other particles like hydrogen gas molecules in interstellar space. There is a suggestive bright spot near the galactic center, perhaps neutrinos generated by the Milky Way's supermassive black hole, but it's not as statistically significant," Dr. Korahashi Nielsen said. As more data is collected, neutrino emissions from the center of the galaxy will become distinct, or it will fade because it was just a statistical fluke. The showering of cosmic rays, gamma rays and neutrinos on Earth shows the universe is anything but calm, with exploding stars and black holes swallowing their surroundings. "We are seeing all of these incredibly violent and energetic processes," said Regina M. Caputo, an astrophysicist at NASA's Goddard Space Flight Center in Maryland who was not involved with the IceCube project. Elizabeth A. Hayes, the project scientist for NASA's Fermi Gamma Ray Space Telescope, said IceCube will provide a new and different view. "Now that we also have the neutrinos," she said, "we can look at those things together to really understand where is energetic matter coming from, in our galaxy and beyond it. It came from a black hole, and landed in Antarctica." For the first time, astronomers followed cosmic neutrinos into the fire-spitting heart of a supermassive blazar. It was the smallest bullet you could possibly imagine, a subatomic particle weighing barely more than a thought. It had been fired out of a gravitational gun barrel by a cosmic blunderbuss, a supermassive black hole. On Sept. 22, 2017, a particle known as a neutrino zinged down from the sky and through the ice of Antarctica at nearly the speed of light, setting off a cascade of alarms in an array of detectors called IceCube. Within seconds, IceCube had alerted an armada of astronomical satellites, including the Fermi Gamma Ray Space Telescope. That spacecraft traced the neutrino back to an obscure dot in the sky, a distant galaxy known as TXS 050656, just off the left shoulder of the constellation Orion, which was having a high-energy outburst of X-rays and gamma rays. While astronomers around the world scrambled to their telescopes to get in on the fun, the IceCube scientists scoured their previous data and found that there had been previous outbursts of neutrinos from the galaxy, which they nicknamed the Texas source, including an enormous neutrino outburst in 2014 and 2015. Sign up to get reminders for space and astronomy events on your calendar. Astronomers said the discovery could provide a long-sought clue to one of the enduring mysteries of physics and the cosmos. Where does the rain of high-energy particles from space known as cosmic rays come from? The leading suspects have long been quasars. They are supermassive black holes in the centers of galaxies where matter and energy get squeezed like toothpaste out of the top and bottom of a donut of doomed swirling material in a violent jet. Now they know at least one in which that seems to be the case. TXS 050656 is a type of quasar known as a blazar, in which our line of sight from Earth is along the jet, right down the gun barrel. The term blazar comes partly from Biel Lachert, a star-like object that turned out to be the first of these objects ever recognized. "We have found the first source of cosmic rays," said Francis Halzen, of the University of Wisconsin, Madison, and IceCube's director, in an interview. Where exactly in the active galaxy the neutrinos are produced will be a matter of debate, he added in an email. It is clear that the supermassive black hole provides the accelerator power, he said, but how is a mystery. The discovery is being announced in a series of papers by an international array of physicists and astronomers in Science and the Astrophysical Journal, and in a news conference sponsored by the National Science Foundation, which funds the IceCube Neutrino Observatory at the Amundsen Scott South Pole Station. I think this is the real thing, said John Learned, a neutrino expert at the University of Hawaii who is not part of IceCube, in an email. The true beginning of high-energy neutrino astronomy, of which we have dreamed for many decades.